Alright, your last video, I'm sure that's got to be pretty exciting here for us. So this last video, we're just going to talk about some of the cautions when we're talking about looking at this relationship between two quantitative variables. So these are kind of big ideas to remember and pay very close attention to. This first one is a pretty big one. That correlation is not the same thing as causation. That is, just because there's a relationship between two things does not mean that the one really is actually completely causing the other one to happen. So I can look at a plot and it appears that maybe students who, or kids who watch more TV don't seem to do as well in school. That doesn't mean that just because I see that relationship that watching TV is the cause of what's making them not do as well in class. Right? There's a relationship between two things. Doesn't mean that the one is causing the other one to happen. Combining two groups could make things actually look like there's a stronger relationship, or even a relationship that maybe really isn't there if you were to look at things separately, for example. So for example, what I might see for that, so suppose I have these red dots represent one group. So if I look at just those red dots, there doesn't really seem to be much going on. But if I put these maybe together with some blue dots, and also the blue dots, if we look at them separately, don't really have much going on. But man, now when I put it together, well, look at that positive relationship there. So it's a little thing that we want to be careful of doing. The third caution we have here is the idea of nonlinear patterns. So always look at a scatter plot first. Because let's suppose that I look at my graph, but I forget to look at my graph and my data looks something like that. Alright, if I look at my plot, to me that's pretty obviously curved, because I can kind of see this angle that it's turning. Right, but StackFront or any software I know doesn't know better. It'll fit a straight line to it. It'll look something like that. Alright, that doesn't actually seem to fit my pattern very well. And I could actually still, and this could give me a pretty good correlation. This could give me a correlation of 0.9, making me feel like, wow, that's a great correlation. There's a really strong relationship going on. Well, the problem is that you shouldn't fit a straight line to it in the first place. So we do like to be careful about doing that. Extrapolation has been an idea that we already talked about. I'll go ahead and define it here more specifically for you. The idea of extrapolation. So first of all, it's a bad thing. So what it is doing is it's predicting far outside the range of your data. So think about, especially like in businesses, we do small extrapolations, but not necessarily this far. So let's suppose we have the last 20 years worth of sales data. I mean, it's probably a pretty reasonable thing for me to use the last 20 years to predict what's going to happen in the next couple of years. But if I try to use the last 20 years of data to predict what's going to happen 20 years down the road, that's not going to give me a very accurate picture of what I can expect to see, because that's so far outside where I have data that I really don't know what's going to happen. So again, so a big thing to remember about extrapolation, so some people will use this fancy word because a lot of people won't know what it means. The biggest thing I want to remember about the word extrapolation is that this means it's a bad thing that they're actually doing here. And finally, the idea of the influential points or outliers, of how that can actually affect things. So let's actually look back at that correlation by eye we were looking at before. So let me kind of get one that's a pretty strong relationship. So let's look at this one. This one has a pretty strong positive relationship. And so I'm going to say that this is pretty close to 1. And it actually turned out to be 0.94, right? A really strong relationship. So I'm just going to add a point up here, which would be a very strong outlier. Look at how that changed our correlation. From 0.94 to 0.5747 by adding one little point. Let's add another point and see what happens. Let's add one also way down here. Wow, now look at that. If I just add these 4 little points, let's make it 5, I've now got a negative correlation. So the fact that these outliers can actually have a pretty big impact. We started with a correlation of 0.94, and then I added those 5 points, now I'm negative. So we want to be careful of how single points can really actually impact things as well. Alright, so those are just, again, things to be careful of whenever we're doing this. So big things to kind of take away here. Always look at a plot first, whether we're talking about regression or any other type of data that we're looking at. We always seem to skip over plots sometimes, so because plots are like, oh, that's middle school and high school type stuff, right? I did plots back then. Plots are still very important for us to kind of just see what's going on, so I know what makes sense to do. So never think that looking at plots is a bad thing. And then also, right, that's the big idea of making sure you're kind of fitting the right equation to what you're doing, understanding the implications of what you're actually saying, so I can't say that one thing is actually causing the other one to happen. So some big takeaways in this set of notes kind of actually apply to a lot of statistics that we've talked about in the course.